In this video, we're discussing compound interest and the compound interest equation. And this is a special type of exponential function. So we've learned about exponential functions. These are functions that have a starting value and a multiplier. They're nonlinear functions. So we're going to look at this special type where we are given a certain amount of money that we put into an investment account, a savings account, that earns interest over time. And depending on how many times we choose to calculate that interest per year, the amount of money that's in the account may change. So you can see first we have our equation, y equals p times the quantity 1 plus r over n, all of that raised to the nt power. So the 1 plus r over n is our multiplier. So think about exponential functions. If we were doubling the quantity every time, the multiplier would be 2. And our p-value is our starting value. Okay, and in this case, what we do is we call P our principal, the principal amount of money that we put into our account, our initial amount. The other two variables are R. R is our annual interest rate, but make sure you take that percentage and you write it in decimal form. Whenever we work with percentages, we want to work with the decimal form of them. And finally, N is the number of times the interest is compounded per year. So if interest was compounded annually, that would be once a year. If it was compounded weekly, for example, N would be 52 because there's 52 weeks in a year. So our first example says you deposit $100 in a savings account that earns 5% annual interest compounded yearly. Write a function for the balance after t years. So before we start writing the equation, I want to identify all of our variables that we know. So the first thing we know, our principal is our starting amount of money, which is how much we deposit. That would be $100. The next thing we know, R, is our interest rate. So I'm going to take my 5%, and I'm going to move that decimal point 2 places back so I can write it as a decimal. So R is equal to 0.05. The next thing I know is how often the interest is compounded or calculated. So here it says we're compounded yearly, so n is 1 time per year. All right, we're not given how many years, so t is just going to stay as a variable here. We don't actually have a number. So when we start plugging things into our equation, we get y equals our p-value, which is 100, times the quantity. So we put parentheses, 1 plus r over n. R is 0.05 over 1. All of that raised to the n times t power. N is 1, t stays as a variable. And if we do some simplifying, we would get y equals 100 times 1.05 raised to the t power. All right, here our starting value is 100, and our multiplier would be 1.05. So just a little bit of growth. In this next example, we're going to practice actually typing one of these equations into our calculator because there's a lot of steps involved and you have to be really careful when you're working with your order of operations. So first, we're going to set up our equation after we find our different quantities. So it says find the balance of a savings account after 15 years for $900 earning 3.5% interest compounded quarterly. So again, a lot of information. It's really important to write out what you know before you dive into it. So first, the principal. The amount of starting money in the account is $900. The next thing we can do is find our interest rate, R, and we're going to move the decimal point 2 places back, so that would be 0.035. Our t value is how many years we're going to leave that money in the account, and this is 15 here. And finally, n is compounded quarterly, so that's 4 times in 1 year. So n equals 4. All right, so let's go ahead and plug that into our equation. We get y equals our p-value, 900, times the quantity 1 plus r, 0.0 0.035 divided by n, which is 4. And that's raised to the power n times t, which is 4 times 15. All right, so order of operations is very important. PEMDAS, parentheses is first. So inside my parentheses, I can see that I have a division problem. So I'm going to first do 0.035 divided by 4, and I end up with 0.00875. So that's my first step. Then I'm going to add 1 to that. So that's 1.00875 once I add 1. I've now completed what's in the parentheses. So you can see my equation is now looking like this. Y equals 900 times 1.00875 raised to the 4 times 15th power. All right, our next step, let's figure out what 4 times 15 is. So we type that in our calculator, and we would get 60. So we can change our exponent now to 60. So our fourth step for typing, let's do the exponent next. PEMDAS. We did the parentheses, now we'll do exponents. So 1.00875, all of that raised to the 60th power. Okay, and that's going to give you about 1.6866 with some other numbers after that. If you keep that in your calculator, our final step is multiplying that value by 0, or by the p-value, which is 900. So we're going to take 900 times 1.6866, and we end up with approximately $1,517.94. Okay, so make sure that you've tried that in your calculator and see if your answer matches what I got up here. And think about what this means. So we started with $900. After just 3.5% interest in 15 years, we nearly doubled the amount of money. 900 to 1,800 would be doubling it. So that's a pretty good amount of interest that we earned over a fairly short amount of time, 15 years. So the next section here, we're going to compare what happens if you compound your interest at different amounts of time. So we're going to compare compounding yearly, monthly, and daily, and see the effect on the output for the money. So first of all, our principal isn't going to change. We're going to always invest the same amount of money. Here we're given for graduation $500 from our family members. And we decide to invest it into a savings account that earns 4% annual interest. So my R value is 0.04, written as a decimal. It says we're trying to decide which option is best, compounding yearly, quarterly, or monthly. So calculate the amount of money for each if we assume that we leave the money in the account for 30 years. So T, in this case, is 30 years. So what's changing is my N value. Compounded yearly, N is equal to 1. Compounded monthly, the number of times per year would be 12 times, since there's 12 months in a year. And if we're compounding our interest every single day throughout the year, N would be equal to 365 for our third equation. Okay, so we can step through typing this in. We'll set up our equation. Y equals 500 times 1 plus R 0.04 over N. I'm going to write this in green just so that we can see what's changing. And that's going to be raised to the 1 times t power, which is 30. 1 times 30. So when I start to type this in, I'm going to do the 0.04 divided by 1 first. So that's just 0.04. So this turns into 500 times 1.04 raised to the 30th power. And if you type that in, you should end up with $1,621.70. So there's our first value, compounded yearly. Compounded monthly, we're just changing the value that's written in green here to 12. So y equals 500 times 1 plus 0.04 divided by 12 raised to the 12 times 30. Everything else stayed the same. The p-value, the r-value, and the t-value don't change here. So when I start to type this in, I'm going to do everything in the parentheses first, which gives me approximately 1.0033. And 12 times 30 is going to give me 360 as my exponent. And then finally, when I start to type this in, my answer would be $1,656.75. So take the time, pause the video, practice typing that in. It's really important that you know how to do the order of operations to get the correct answers here. And looking just from these first two answers, we've got compounded yearly is 1621, compounded monthly is 1656. So a little bit bigger. If you think that trend would continue, since we're compounding more frequently when we compound daily, we'd expect a number larger than 1656. So let's go ahead and see what happens here. We get y equals 500 times 1 plus 0.04 divided by 365. And if we close our parenthesis, that's going to be raised to the 365 times 30. So we'll look at the inside first. That turns into approximately 1.00011. And our exponent turns into 10,950. And after we type that in, we end up with $1,659.95. So over the course of 30 years, if we compound daily versus monthly, we really only ended up with $3 more. So it's not a huge difference, obviously. But if you think about our principal amount, $500, that's not a very big amount of money to put into a savings account. So if you're investing a lot more money, the difference would actually be greater down the road. So the final question here is one for you to try on your own. You're given an explanation of how much money you have, what the rate is, and all that. So find your variables and make sure you write out what the variables are and show your calculations to get your final answer.